Transformations of functions. As you advance through higher mathematics courses, it becomes useful to be able to make quick sketches of graphs without plotting points or using a graphing calculator. Some common functions in their basic form, called paragraphs or parent graphs, should be memorized. Here are 6 parent graphs that are good to have memorized. Linear, y equals x, is just a straight line. Quadratic, y equals x squared, is a parabola. Absolute value, y equals the absolute value of x, is a v. Notice the parabola, the v, are anchored at 0, 0. All of these graphs are. The cubic graph, y equals x squared. To draw this, I always think of drawing a smile on the right side and a frown on the left side. The square root function, y equals the square root of x, starts at 0, 0 and gently curves up to the right. And the cube root function, y equals the cube root of x. When numbers are added, subtracted, and or multiplied to the parent graphs, the graphs move, rotate, and stretch or shrink. This is a guide to tell you what numbers and operations do what things to your graph. We'll go through most of these in this lesson. We will not be doing horizontal stretching or shrinking, but we'll come across most everything else. So the A, B, C, and D will be numbers that can be used to alter your parent graph. And so it's good to identify the A, B, C, and D for each problem. Things that happen to the outside of the function are vertical, and they do what you would expect. So when you look at A, it says vertical, and then if A is greater than 1, it stretches. If A is less than 1, it shrinks. So a big number stretches, a small number shrinks. Also on the outside of the function is D, which moves the graph up or down. Plus is up, minus is down. That's what you would think. On the inside of the function, something is on the inside if it's trapped with the x, such as inside a parentheses, inside a square root, inside absolute value bars. So things that are on the inside are horizontal, and they do the opposite of what you would expect. So B is a horizontal shrink or stretch, but the larger numbers shrink, the smaller numbers stretch. The plus or minus C has to do with moving to the left or to the right. Plus is to the left, minus is to the right, which is sort of backwards of what you would think. So let's start with numbers being added or subtracted to the outside of a function. This causes the graph to be shifted up or down. So here we see the parent graph, y equals x squared. And we're going to add 2 to the end of that. So the 2 would represent the D in the formula we just looked at. And because it's a plus, we move our graph from being anchored at 0, 0, we move it up 2 and draw a quick sketch of a parabola. The next one is minus 2. So that means we should move the graph down 2. These graphs are meant to be drawn by hand. Don't draw them on your graphing calculator. But I screenshotted the calculator because they look nicer. Now the next group is when you have a graph with the number added or subtracted inside the function. And so in the next set, we're still looking at the parent graph y equals x squared. And then the second one is in parentheses x plus 2 squared. So the 2 is trapped inside. That means it's C. The number in front of the x is B, which is a 1. Now for this lesson, B will always be 1. And if it's a 1, it's not a stretch or a shrink. It doesn't do anything. So we're not going to worry really about the B. But technically, when you move left or right, it's C divided by B. But like I said, in this lesson, B will always be 1, so we can just look at the C. Plus 2, backwards of what you would think, moves the graph left 2. And then the next one, minus 2, moves the graph to the right 2. When a negative is multiplied on the outside of a function, the graph will flip vertically. So if you look at the parent graph of y equals the square root of x, you can see what that looks like. And then when we put a minus in front, that causes a vertical flip. That's an up and down flip. Some books call this being reflected across the x-axis. So it's flipped vertically, that's an up and down flip. If the minus goes inside the function, like the next example, then it's a horizontal flip, which is a left-right flip, and some books call that reflected across the y-axis. Applied to a function cause the function to stretch or shrink. When a number, which we call a, is multiplied on the outside of a function, a vertical stretch or shrink occurs. If a is greater than 1, it's a stretch. If a is less than 1, it's a shrink. So let's look at the graph of y equals x cubed. There's the parent graph, smile on the right, frown on the left. The one beside it says y equals 4x cubed. We have a number on the outside being multiplied, so that's a. And it's a vertical stretch because a is greater than 1. Now to visualize the vertical stretch, think of the graph as being pulled apart from the top and bottom. This makes the graph more narrow. For a vertical shrink, which is the next one, y equals 1/4 x cubed. Because 1/4 is less than 1, it's a vertical shrink. Think of the graph as being squashed from above and below. And that makes the graph more wide. Now let's look at some examples of types of problems you'll. It says use transformations to sketch the graph. Make sure you also write the transformation. If you're moving something 5 places to the right, then write right 5. This is a 4 being multiplied on the outside. It's greater than 1. So I